Welcome back to my channel, Geophysics for Everyone. I do hope that you enjoyed the video. Thank you. Today we are going to talk about measuring the electrical resistivity of rocks. This video is a part of videos intended for a course at Institut Teknologi Bandung. The course is Elementary Geophysics for a second-year geophysics student. So why you need to know how to measure the physical properties of rocks? Geophysicists should have hands-on experience on how to measure basic physical properties. Geophysicists should also have sense of magnitudes when it comes to physical properties. In these courses, the students are required to do several measurements of physical properties. One of them is measuring the electrical resistivity. The students will be provided with long cylindrical samples as well as the iron sand samples and pyroclastic samples. The students would also be provided with special holder. This is the holder that the student would use to measure the electrical resistivity of iron sand or electrical resistivity of the pyroclastic samples. Please note that there are places, the rings, and this is the place where the students could connect the electrodes to the samples. So the students will have access to a current generator. This is the one that is used to supply current to the samples. And then there's a digital multimeter connected to the electrodes in the samples to measure both the current as well as the potential. The students will also have access to a caliper. First of all, the students are required to measure the volume of solid sample as well as the internal volume of the glass sample holder. The students are then required to fill up the glass sample holder either with iron sand or pyroclastic samples. The students are then required to place the electrodes, the copper plates for current electrodes and brass rings for the potential electrodes on each sample, and then connect the current and measure the potential. The resistance R is simply the potential V divided by the current I. The resistivity ρ can then be determined using Pauli law, where A is the area of sample cross-section and L is the length of the sample. So you could see the formula here. There's some cautionary notes when it comes to measuring electrical resistivity. Again, please measure the heights and the diameter of your samples multiple times, and also the same for measuring the current and the potentials. The students are also required to describe and identify the rock samples so that they could check the measured value with that in the literatures. The laboratory assistant will help the students to operate the instruments, so no worry about that, okay? The students are then required to make a report, and apart from the electrical resistivity of their samples, the students are required to identify the rocks and compare their findings with that in literature. In the next video, we'll be talking about measurements of seismic wave velocity. Thank you for watching. I hope you enjoyed the video. I'll see you later. Bye-bye.